Okay, this is literally the third time I've recorded this video. I just want you guys to be able to see, yes, the microphone is on this time. I did just finish a lovely soup. Okay, composite functions. Turn your brain off, use a highlighter. Sorry, drinking some pear juice. So, we know f of x equals x plus 2. F of 0 is then 0 plus 2. So f of 0 is 2. F of x is, well, we know f of x. Oh, hang on. No, they've asked us f of 0. Well, again, we know f of 0. It's 2. So I can chuck that 2 in instead of f of 0. Now, f of 2, you know, is just 2 plus 2. I'm just chucking 2 in for x, so it comes out as 4. With question 4, we know f of x equals x plus 2, which means f of negative 8 is negative 8 plus 2. So f of negative 8 equals negative 6. F of negative 8 must then be f of negative 6, because f of negative 8 was negative 6. F of negative 6 is negative 6 plus 2, which gives me negative 4. For question B, I've got f of x. Well, I know that f of x is x plus 2, yeah? Which means f of x equals, I know f of x was x plus 2, so I'm going to substitute in x plus 2 here. F of x plus 2. What this means is that instead of x in my original equation, I'm going to chuck in x plus 2. So I've got x plus 2 plus 2. So that x plus 2 is from my function, which gives me x plus 4. And if I had f of x, so this was f of x, and I'm going to colour that blue. Well, I know this means that that's f of x came out as x plus 4. So what I'm doing is I'm going to chuck x plus 4 in instead of x. So I've got x plus 4 plus 2, which gives me x plus 6. For question 3, find the value of x for which f of x equals 0. So if f of x equals 0, well, I know f of x, it came out as x plus 4. So I know x plus 4 equals 0, so x is negative 4. Question 6 knocks it up a tad. So let's start off by trying to find these. And we know L of x equals x take 3. Q of x equals x squared. Okay, so this one asks for L of Q of minus 1. We've got Q of L of minus 1, we've got L of minus 1, and we've got Q of Q of minus 1. So we should find Q of minus 1 and L of minus 1. Q of minus 1 is just x squared with minus 1 instead of x. Minus 1 squared, which comes out as 1. So Q of minus 1 equals 1. L of minus 1, well, L of x was x take 3, so we've got minus 1 take 3. So L of minus 1 equals minus 4. Don't ask me why they've done a weird L. So that's that one. That's that one. Then, if I would like to find L of Q of minus 1, Well, that's the same as L of, what did we decide was Q of minus 1? 1. So L of 1, I'm just subbing in 1 for x. So I've got 1 take 3, which is minus 2. If I'm doing Q of L of minus 1, then that gives me Q of, well, L of minus 1 came out as negative 4. Negative 4. Q of negative 4 is negative 4 squared, which is 16. L of minus 1. Well, L of minus 1, we know it came out as negative 4, so it's L of negative 4, which is the same as negative 4 take 3, which is negative 7. And Q of minus 1. Well, we know Q of minus 1, it's 1. So that's Q of 1, which means I've got 1 squared, which is 1. Hooray! Then if I would like to find L of Q of x, now, Q of x was x squared, so L of Q of x, so this time I'm literally just substituting x squared in for Q of x, which means I've got L of x squared. Now remember that L of x is x take 3, so here I'm just substituting x squared instead of x, which then gives me x squared take 3. If I have Q of L of x, then I have Q of, well, x take 3. Now Q of x was x squared, so what I'm going to do is x take 3 squared. If I want L of x, then that's the same as L of x take 3. And that's the same as x take 3, which is x take 6. And if I would like Q of x, then that's the same as Q of x squared. So I've got x squared, so I've got x to the 4. The domains and ranges of L and Q of x, which was, we've figured it out, x squared take 3. I'm going to draw it, just not well, obviously. No one bothers to draw these things well. It's just a normal parabola that's been moved down 3. So it's going to go like that. So the domain, don't forget when you're looking for domain, you're looking to see if x is on the bottom of a fraction or if there's a square root. Anything else kind of just goes. So there's no number that we couldn't chuck in here for x, so it's all real x. And the range, I like to look at the diagrams, the drawings for my ranges, okay? I always find them easier. Well, y is greater than or equal to negative 3. Because it doesn't matter what you chuck in for x, the smallest number you could possibly get for x squared is 0, which means the smallest possible number we could get for this function is 0 take 3, which is negative 3. And I shouldn't have called it y, I should have called it L of Q of x. Okay, Q of L of x came out as x take 3 squared. So if we draw that, it's always good to draw these. Now that's just a normal parabola that's been moved right 3. So it looks like that, which means the domain, again, there's nothing we couldn't chuck in for x, so all real x. And the range, it doesn't matter what we chuck in for x, it's always going to be greater than or equal to 0, like it's squared, so it's always going to be positive unless you chucked it in 3, then it'd be 0, so y is greater than or equal to 0. What transformation maps x squared to Q of L of x, which was x take 3 squared, moved right 3. And x squared to, well, L of Q of x was x squared take 3. And that moved it down 3. Moved down 3. That's questions 1 and 6.